Hey. Hey everyone, can you hear me? Cool. Hi, I'm Brandon. I'm the CEO of o1Labs. We build Mina protocol and Project Untitled.
I'm Austin. I work with Brandon. So yeah, we're together going to talk mostly about Project Untitled today. So I'm one of the co-founders, and we're really excited to talk about this problem. Do you want to get started?
So anyway, like I said, we build this stuff. We have a proof system. We have o1.js. We recently did a mainnet upgrade in Mina that enabled smart contracts. I'll fast forward through this, but basically, this upgrade, it's the first time that we had a general purpose programmability layer that really could utilize ZK and privacy on a mainnet, and so we learned some things. So basically, what we're trying to do at o1Labs in general is to enable an internet that uses programmable cryptography to allow developers to build more powerful applications. The way that we think about this is we can kind of break this down into 3 different slices. If we think about each one, Mina right now does a really good job at the settlement layer. It can take proofs and kind of recursively combine them down. You can compose and build on them and do interesting things to kind of build with Mina in this way. And there's a bunch of applications that are doing so. And then on the application layer, we have o1.js. But there's some stuff with the platform that we're working on to make it better. There's some things that we're learning on mainnet, but we're not going to talk about that today. The third thing, we totally skipped with Mina. Mina is this tiny blockchain that you can't really store anything. There's a tiny bit of state on chain, but you're meant to store a Merkle root and then store your data elsewhere. And it turns out developers aren't happy with this. So we thought about it.
Yeah, so Brandon got to talk about the good things around Mina, which is the settlement layer and the part of our execution layer. But honestly, when we looked around at the Mina applications, they're all running into the same problem. There's a state management problem with Mina, and we're up there in front of everyone acknowledging this. There isn't enough state on chain for developers to interact with. And specifically, there isn't really a solution that optimizes for decentralization, low storage costs, and low latency. So then, once we talked to the Mina community and we realized this is a core problem, we took a step back, and similar to the talk previous, we realized that there's actually a large state management problem across Web3. And until very recently, and this is the project that we're going to spend most of today talking about, there is not really any solutions that optimize for decentralization, low storage cost, or low latency. So that's what we're building, and we're calling it Project Untitled, name to come soon, we're working on it. But this is the mutable state solution that's going to power the next generation of ZK apps. So this is what we're building. It's built on the back of polynomial commitments, and it's built by us at O1, the same team that built Mina. So what is it? It's a few things. So it's going to be like a dedicated protocol, like a standalone L1. It's going to be its own state management layer. Like I mentioned, built on polynomial commitments, so it enables really scalable state updates that are really fast. It's going to be accessible not just from Mina, but for all of Web3. So we want to solve this problem for the entire ecosystem, and there's obviously going to be a dedicated incentive layer. So how is it going to work? The analogy that I've been using the most is to think about it kind of like state diffs. So when you're just contributing to a repository, you don't just take the entire repository when you make one line change and then rewrite that repository again. You just change the one line. You just change the diff, right? So what we're envisioning is something that's very similar, but now just think about this for any application state. All you need to do is if you change all of your swords from red to blue, you just change one little bit of that data. And that's the only thing that needs to be updated. And we're doing this based on the back of polynomial commitments. There's some prior art there and some good learning. Long term, what you can do then is if you have all of your state living on this chain, we can then send the execution to where the state is and then effectively have no latency across those two systems. So that's really interesting, and that's in the very coming soon, later bit. But there's some interesting end state for what it looks like when you have state and the execution on the same layer. There's some really interesting categories as well. We'll get into that in a minute. I don't want to spend too much time on this because what this is really supposed to illustrate is just it's going to be its own dedicated system. you're able to interact with it from any base chain. So think about it like simply you've got like a user that submits a transaction through an application. That application then has a contract that processes that sends a message to a project Untitled bucket. So think of it like a state bucket. Then through like the actual network itself, the node ops will fetch like the current state, process the transition, and then send the execution proof in the state diff back to that application, likely using some sort of bridge. I want to like just hit home on why this is important. And I want to talk about like one of the games that we like one of the most popular games in the Mina ecosystem. It's Tileville. It's like, think about it like there's hundreds of players using it. It's kind of like a Settlers of Catan style game. And there's like game state. Like this grid is basically an 11 by 11 grid where you like update and you put your tiles on it. And then if you arrange your tiles in a certain way, you get a high score. They generate state. They want to constantly mutate state, and they run tons of tournaments. Unfortunately, they've had to make some pretty centralized trade-offs with how they store the data because they weren't able to get a solution that, or use a storage solution that they can mutate state really quickly with. So game data can be disputed right now. That sucks. So we want to solve that for them, and they're kind of blocked by us shipping this thing. So that's just the Mina ecosystem. There's projects outside of this, outside of just gaming, social, aggregators, and Brandon's going to talk about an interesting corner.
Yeah, so how much time do I have? No, okay. So there's this cool book from the 90s called The Diamond Age by Neil Stephenson. Who's read it? Raise your hand. One person. Cool. Okay, so this book, it's really cool. It made some predictions about AI and like other cool futuristic things. And actually one part of the book, like a part of this world that gets built that isn't about AI, but is this idea of there's engineers who can build little robots out of atoms that fly around the air and they can like multiply and do different things. And these like nanobots have basically filled the air all around the world and are like in people's bloodstreams. And of course, there's like viruses. And then there's antiviruses and kind of like the war that's going on in our bodies with germs and viruses and our immune systems. This is happening with like these virtual robots. You might ask like, why the fuck am I talking about this? But I'm gonna bring it back, right? Okay. So this is kind of a cool world, and what I think this is kind of a metaphor for, or it's gonna predict the future is. Whether we like it or not, the world is going to have, hundreds of thousands or millions of AI agents kind of floating around everywhere in the air and in our bodies, metaphorically. Obviously, they're like in virtual space. And this is just going to happen. This is pretty generally accepted in like the AI spaces in San Francisco, from what I understand. And I believe it, and I can argue and justify it later. So this world is like kind of weird and crazy, but I just want to talk through like one slice of it, and then you'll see how I wrap it up back to Project Untitled and Mina. So, okay, let's think about food, okay? So it's the future, and it's like a few years from now. I'm not talking about like 100 years from now, like a few years from now. I have, in my thousands of AI agents that are like on my person, reading sensory inputs from my body and the sounds and sights around me. Some of them are responsible for like understanding my allergies, the things I hate, the things I love, the things I'm intolerant to, right? And so these things, like they're listening to the words I'm saying. Maybe they're plugged into like my organs and understanding how the nutrients that I'm ingesting is affecting the health of my body. Like anything like that, right? And these agents, they're all aggregating this information. Okay, so they're reading these sensory inputs, they're making inferences, and then recording this information somewhere. Okay, and then when I walk by a restaurant on the street, the AI agents at the front of house at the restaurant will be starting a negotiation with the AI agents in my body. And say like, hey, you should eat here. Here's how much it costs. Here's the food we have. And then the agents in my body that understand about me are gonna say, hey, there's gluten-free stuff and you're gluten-free, so it costs the right amount and I'm hungry and all these things, right? And so let's say you go in this restaurant, right? Then you need to order your food, but maybe your AI agents order for you, and they talk to the agents in the kitchen, and the agents in the kitchen work with agents in robots to cook your food and whatever, and bring it to you and you eat. Okay. So if we just think about like this slice of information, I don't know. You can believe me or not. But I think this will happen. There's information that I have that I want to keep private most of the time. For example, like what I'm allergic to, okay? Like, I don't want the whole world to know I'm gluten-free, which I am, by the way. Like, I'm allergic to gluten or something. I don't know, it makes me feel sick. I don't want the whole world to know that. YouTube's gonna know it now, but whatever. But in general, like there are things about my health that I want to keep private. But not only do I not want the whole world to know that, I don't want like all the restaurants in the world to know that, but holy shit, if I'm gonna go and eat at a restaurant, they better know what the fuck my allergies are, right? And so it begs the question, like, how can, where and how am I gonna store information that is private but available and can be shared in specific situations? And I think it turns out if you have a system for storing data that's based on polynomial commitments, which is like half of a ZK proof anyway, you can build a permissioning system on top of it really easily that's robust and uses ZK proofs to kind of determine the specific situations in which I want my information to kind of be authorized. And I think, basically fit in as like the infrastructure layer or memory layer for this future with AI agents. And so it's something that I think is kind of cool. And I think maybe Project Untitled fits in. And I want to hear from people if you think this is really stupid or you think this is really cool. Because, yeah, so it's cool. So anyway, we're building this thing. And we have a white paper, a draft of a white paper. Some stuff are stubs that we released recently. You can join our Telegram community and read about our stuff. Talk to us. I think we open sourced our repo already, and we're like committing lots of code. So yeah, that's it.